The cosmos moves fast and uniquely, and mankind makes daily progress in its comprehension of the world around us. Since the creation of space technology like the James Webb Space Telescope by the U.S. National Aeronautics and Space Administration, or NASA, space exploration has become significantly easier. It is capable of seeing objects as far away as the center of the Milky Way galaxy because of its superb infrared resolution technology and high sensitivity. Unexpectedly, the James Webb Space Telescope discovered a massive structure while studying the components of the Milky Way, and this huge structure is older than the universe itself. What is it? And how does this discovery affect cosmological research? One of NASA's biggest accomplishments is the James Webb Space Telescope, originally known as the Next Generation Space Telescope. The multi-billion-dollar telescope was dedicated in September 2002 in memory of James E. Webb, who directed the Mercury, Apollo, and Gemini programs while serving as NASA administrator from 1961 to 1968. Cosmologists' perspectives and how they view the entire solar system have been revolutionized by the James Webb Space Telescope, which has proven to be a fantastic invention. The main purpose of this stunning invention, which is now the largest optical telescope in orbit, was to observe and investigate astronomical objects in space using infrared light. On December 25, 2021, an Ariadne 5 rocket was used to launch the James Webb Space Telescope into orbit from the spaceport in French Guiana. The Space Telescope was designed and constructed by the Canadian Space Agency and the European Space Agency. For the $10 billion project, Northrop Grumman was the principal contractor. The James Webb Space Telescope has to be kept at a very low temperature of -223 degrees Celsius to continue working. This is required to prevent infrared light from the telescope itself obstructing the light coming in. With 5 fewer sun shields protecting it from the Earth's moon and the sun's warming effects, this extraordinary gadget is positioned in a solar orbit close to L2, the Lagrange point, 1.5 million kilometers from Earth. A few weeks later, on January 24, 2022, the mission team accomplished a critical step by activating Webb's thrusters to launch the Space Telescope into its targeted orbit. The location of the James Webb Space Telescope gives us a perfect broad view of the cosmos, while also enabling scientific instruments and optics to stay in a cool enough environment for this great technology to function and carry out regular science experiments as it was intended. The first deep field of the Space Telescope is the sharpest and most detailed infrared image of the far-off universe ever taken. One of the largest and faintest lit objects ever seen in infrared is in this image, Galaxy Cluster SMACS 0723. Further images taken by Webb's cutting-edge scientific apparatus were made public to show the telescope's progress on July 12, 2022. The objects in these images are Stephan's Quintet, WASP 96b spectrum, Southern Ring Nebula, and the Carina Nebula. Recent findings have given rise to a brand new cosmic creation story. A stellar nursery, called 30 Doradus, is the location where hundreds of brand new stars that have never been observed before have been found and captured on camera. Because of the appearance of their wispy filaments in previous telescopic images, these young stars were given the moniker the Tarantula Nebula. When seen using the near-infrared camera of the Space Telescope, the region resembles the home of a burrowing tarantula. It has long been a tradition to study the Tarantula Nebula when studying star formation. The James Webb Space Telescope's images also showed distant background galaxies and the intricate structure and makeup of the nebula's gas and dust, which provide support for the forming stars. The galaxy closest to our Milky Way, is the Large Magellanic Cloud, which is 161,000 light-years away and contains the most massive and hottest stars known. Looking at the image, one can see that the cavity of the nebula has been filled by powerful radiation from a cluster of young stars that shines in a pale blue color. Recently, our galaxy was discovered to contain a giant filament of atomic hydrogen gas by a multinational team of astronomers under the direction of the Max Planck Institute of Astronomy. One of the longest formations ever seen in our galaxy, dubbed Maggie, is situated around 55,000 light-years away, on the other side of the Milky Way. Jonas Syed, a PhD candidate at the Max Planck Institute, was the study's principal investigator. It was just published in the journal Astronomy and Astrophysics. Researchers from the University of Calgary, the Universität Heidelberg, the Center for Astrophysics and Planetary Science, the Argelander Institute for Astronomy, the Indian Institute of Science, and NASA's Jet Propulsion Laboratory joined him. They were also joined by researchers from the University of Vienna, the Harvard-Smithsonian Center for Astrophysics, and the Max Planck Institute for Radio Astronomy. The study is based on data from the Carl G. Jansky Very Large Array in New Mexico's HIOH Recombination Line Survey of the Milky Way, an observing program. This project investigates molecular cloud formation, the conversion of atomic to molecular hydrogen, the magnetic field of the galaxy, and other issues concerning star formation using the centimeter wave radio dishes of the Very Large Array. The overarching goal is to understand how the two most prevalent forms of hydrogen gas combine to form thick clouds that give birth to young stars. Atomic hydrogen, which consists of one proton, one electron, and no neutrons, and molecular hydrogen, which consists of two hydrogen atoms bound together by a covalent link, are the two forms of hydrogen in question. Only the latter condenses into somewhat small clouds that eventually give rise to icy areas from which new stars can eventually form. This exceptionally long filament was particularly fascinating since it provided new information about the process by which atomic hydrogen transforms into molecular hydrogen. The erosion caused by the stellar winds from these stars can only be withstood by the nebula's highly populated surroundings, resulting in pillars that appear to face the cluster. In these pillars, there are forming protostars, which will someday emerge from their dusty cocoons and reshape the nebula. The James Webb Space Telescope discovered a very young star performing this action as it was circling and watching in space, even though the close speck displayed on the star was only just starting to emerge from its pillar. Without it, the star formation process would not have been visible. Any time brilliant stars and cooler gas are found by the mid-infrared detectors of the Space Observatory, it is safe to assume that the region is observable at longer infrared wavelengths. In such cases, the area seems completely different. Shorter light wavelengths are either absorbed or scattered by the nebula's dust particles as trapped protostars grow in mass. The stellar nursery cloud's points of light start to become apparent. The previously unseen cosmic environment may now be seen because longer infrared wavelengths can now pass through the dust. The chemical composition of the Tarantula Nebula is consistent with the sizable star-forming region that was found in the universe when it was barely 1 billion years old. The development of stars was at its pinnacle. The star-forming regions in our Milky Way galaxy do not generate stars at the same alarming rate as the Tarantula Nebula because they do not have the same chemical composition. Due to its unusual composition, the Tarantula Nebula is the best example of what is happening in the universe. But we wouldn't be able to research it and compare views of star formation without the James Webb Space Telescope. This brilliant invention is just beginning its mission to rewrite the history of stellar creation and is allowing us to witness things that were previously invisible to us. What do you think? Please tell us in the comments below, and if you enjoyed this video then please don't forget to give us a like, subscribe to the channel, and we'll see you next time. Thanks for watching.